Anya, and today I'm going to be talking about Python Advanced Lesson 3. So the goals for today are learning what is object-oriented programming, what are classes, the 4 pillars of object-oriented programming, how to code a class, and we're finally going to wrap up with a mini project, the virtual zoo. So our motivational quote of the day is "You are never too old to set another goal or to dream a new dream" by C.S. Lewis. So what is object-oriented programming? Until now, our code ran purely line by line using individual isolated variables and independent functions. Object-oriented programming is an approach where we organize code around objects, self-contained bundles that package data together with the actions they perform. So we can break our code up using these virtual objects. So object-oriented programming is a way of writing code that organizes software design around objects, data, and behaviors, rather than just a sequence of logic. It lets programmers model real-world things and make complex code much easier to write, reuse, and update. So what are classes? Classes are the foundation of object-oriented programming, and they are essentially groups of objects. All objects in a class follow the same architectural blueprint, which is defined in the class as the constructor of the class. Right? Python uses the class keyword to define a class. Right? So notice the standard uppercase name style for the class. A single blueprint block can yield thousands of completely distinct separate user objects in memory. Right? So for example, in our class hero, we have multiple instances that we can create. So player 1 in our class hero would be an object of the class hero. So the class versus the object is something that is really important. So the class is a structure template written in code, and it defines what attributes, variables, and what methods or functions a type of object will have, but it doesn't actually hold data. The instances, or the objects, are groups in the class which have specific data assigned to them. And these objects, which hold the data, have access to all of the methods in the class. The object is a concrete entity constructed from the specific class blueprint, and its allocated space in memory contains active standalone state values. So we looked at how a class turns into a specific instance. Now let's reverse it. Look at these real-world objects and think to yourselves, what is the generic class blueprint? Right? So essentially, we are taking each of these scenarios and trying to model them with a class and object in Python. So in scenario 1, we have a yellow 2023 school bus with a license plate X123. Right? I will be going over the answer in 3, 2, 1. All right. So in this instance, one thing we could do is we could make our class school buses, and our object would be the bus itself, and our object would have the attributes year and license plate with values 2023 and X123. All right, now for scenario 2. We have a specific golden retriever named Buddy who lives next door. So a class we could do for this would be dog or animal. And scenario number 3, the copy of Minecraft running on your computer right now. So the class could be video game or software. All right, now onto the 4 pillars of object-oriented programming. So here's an overview of them. The 4 pillars are inheritance, polymorphism, encapsulation, and abstraction. With inheritance, what happens is child classes inherit traits from parent classes. So how this works is if there is a parent class, you can have a child class, which is a subclass, essentially, of the bigger class. And any child class will have all the properties of the parent class, plus other stuff. So we can duplicate classes, kind of, with making some minor changes by making a parent class and a child class. Polymorphism, which literally translates to many forms, means that different classes can use the same method name with different behaviors. So, for example, both a bird and a robot can, use the method .move, but one flies while the other rolls. Right? Okay. For our third pillar, we have encapsulation, which is essentially bundling data together and hiding sensitive variables from the outside world using double underscores, like self.password, self.__password. So what this would do is it would prevent the password from being changed by something else. And finally, we have abstraction, which is hiding the complexity. So what this does is it shows the user only the buttons they need to press while hiding the complex background math. Like, for example, if we wanted to call player.jump, right, we could write a function for jumping. And every time we wanted to jump, we wouldn't need to copy paste 50 lines of physics logic. All we would need to do is call player.jump. And this would encompass all the functionality of that 50 lines without actually writing out the logic. So, inheritance, the first pillar. If we want to build a bus, we shouldn't rewrite all the code from car, right? A bus is a vehicle. So if we had a class vehicle and we had a class bus that we wanted to make a child of vehicle, you would put vehicle in parentheses of bus, and you could add more methods to it. So inheritance lets a child class inherit all attributes and methods from a parent class. So the super linker gateway. When a specialized child class implements its own custom init block, it overrides the parent's constructor. And a constructor is the thing inside a class. It's the template inside a class for constructing objects. Right? And if a child class overrides a parent's constructor, it would break the base layout initialization. So we can use super parentheses to call the parent class constructor directly. So in Python, it instructs it to run the parent setup parameters first, then let me add my unique subtraits. So how you would do this is inside your child class. You would write def init self, name, and then we would call the parent constructor. So super.init name. And what this would do is it would add name to the list of attributes already specified by the parent constructor. All right, on to polymorphism. Polymorphism literally translates to many forms, and it basically means that different classes can have methods with the same name but different behaviors. So both a bird and a robot might have a .move method, but one flies while the other rolls, as we spoke about before. So in our class bird and in our class lion, we can define like speak, which is another example. And something special about this is that we could loop through objects which are instances of classes bird and lion, and we could call .speak on all of them without knowing their type. And every time it would call whichever object, it would call the .speak method for whichever object it was actually the class, whichever class the object was actually an instance of. Encapsulation. So what encapsulation does is it wraps data and methods into a single unit. Most importantly, we can hide sensitive data from the outside world. Using a double underscore makes a variable private. So this would protect your game from hackers or accidental bugs. So in our example, when we are defining the attribute, we have self dot underscore underscore health, and that underscore underscore makes that variable private. Abstraction. Abstraction hides the complexity of a piece of code. So for example, a car driver only sees the steering wheel and pedals. They don't need to see the thousands of explosions or mechanics inside of the engine. So abstraction only shows the user the buttons they need while hiding the complex stuff underneath. As we talked about before, an example would be player.jump, which could hide 50 or more lines of physics and gravity code, right? But you don't want to look at that every single time you want a player to jump. All right. So here's a little check-in. What would a golden retriever class getting traits from a dog class be considered as? Which pillar would it be? The answer is that this phenomenon where a golden retriever class gets traits from a dog class is called inheritance. Number 2, hiding the password variable from being changed directly. This is an example of encapsulation. Number 3, using a remote.press button without knowing how IR signals work. That is an example of abstraction. And finally, a square and a circle both have an area method. That is an example of polymorphism. All right, how to code a class. To tell Python that there will be a class, we should use the class keyword. On the first line, you type in class car. Car is the name of the class, and then you have a colon. On to initialization. It's called init, and it's a special method which calls the constructor that we call to make a new object from the class. The return of the function is the object itself. Our init function can have parameters like any normal function, but you have to put the variable self at the start, which represents the object to be created. Right? So in this example, we have def init self, brand, color. Self is required in this initiation function and represents the object that is going to be created. Parameters brand and color are attributes of any object that is constructed using this constructor. So here are a few quiz questions. What parameter is always needed in the initiation method? What is the first line to type when writing a class? And what is the syntax of the init function? The answers include the answers to these are: number 1, the self parameter is always needed. Number 2, the first line to type when writing a class is defining the class itself, so class and then the name of the class. And the syntax of the init function, as described on this next slide, is init parentheses self, any attributes you want to add. And then we have our initialization of the class. So inside the constructor, we usually use the parameters to define objects' attributes. And to access an object's attributes, we use self.attribute name. So inside the class, we are setting self.brand. So we are setting the value of self.brand to the brand that was passed in as a parameter. And then we are setting self.color to the color that was passed in as a parameter. So what this function is doing is later when you call the constructor, whatever parameters have been passed in, so self, brand, and color, or not self, but brand and color, those two parameters are on the right side of the equal sign inside the function. So we're telling Python that whenever we say the name of this object dot brand, we want that value to return brand, or the parameter that was passed when the object was created. And same thing for color. All right. Thank you so much for listening. Let's make a method inside the class. Okay. Say we want to run a description of our car, since we have variables for the color and the brand. Like the init function, we always have to have self at the beginning of our function, which is known as a method in classes. Right? So here is an example of a method we could put inside the class. Def return description, self, return, I'm going to drive my self.color plus self.brand. So an attribute versus a method. Data parameters and functional actions are distinctly tracked inside any class container structure. So attributes represent data stored inside the instance container, and they are kind of like adjectives, usually. Right? So an example of it would be self.color equals gold. Methods, on the other hand, are functions that the object can perform, and they usually are verbs. An example would be def jump self. So now we need to make an instance of the car object into our car class that we have created earlier. So this means we need to use the car class we coded and create an object. So here we have C equals car, Mercedes, yellow. In this line of code, we are storing the variable Mercedes in brand and the yellow in color. And if we printed C.return description, we would get our description as we specified earlier, which is I'm going to drive my yellow Mercedes. Right? We don't need to include a parameter for self because Python already knows that you are creating an object. I'm just going to skip this. Right, adding self to the function parameters. So something to remember is that self is always included, so we access our attributes and methods of the objects. And when we call the method, we don't have to put anything inside for the self parameter. Python does it for us. So here is our completed code. All right, on to our mini project. The virtual zoo. Okay, so the instructions are to create a simple zoo simulator using your new object-oriented programming skills. So step by step, you want to create the base blueprint, build an animal class, give it an init constructor that takes name and a species, add a statistic, give every animal a hunger level that starts at 50, and add an action method. So this would be a method. Create a feed method. When called, it prints animal name, eats some food, and lowers their hunger by 10. Test your code. Create two different animal objects, like a lion and a penguin, and call .feed on them to make sure it works. All right, I will be going over the answer in 3, 2, 1. Here is a sample solution. Inside our class animal, we define def init, self, name, species, so that's our constructor right there. And then we have self.name equals name, self.species equals species, and self.hunger equals 50. Everyone starts at half hungry. All right. And then we can create a method, def feed self. And we have self.hunger minus equals 10, print, and then we print the name, species, was fed, hunger is now self.hunger. Right? And we can test it out. And we should get eventually this program should print the Simba the lion was fed, hunger is now 40, and Pingu the penguin was fed, hunger is now 40. Thank you for watching.